this is Unit 12, Assignment 2. The most popular, most requested questions for that one were actually the entire second page, 5, 6, 7, and 8. So I'll walk through them. It's no big deal. This one uses a different equation. It's not Hooke's law with F equals negative kx. It's not our pendulum equation. This is our wave equation, which we're going to be using a lot, both in this unit on waves in general. We'll use it in our unit on sound and in our unit on light. So we're going to be using this one a bunch. One of the biggest sticking points for a lot of students, even you guys first semester when we did this with circular motion, was identifying period versus frequency, which one's provided. So I wanted to put real quick in red the difference between them. Remember, frequency is a number of times something happens divided by the amount of time that took to occur. So it's how often that event occurs, whatever it is. Period is the exact opposite. It is the amount of time that transpired for usually one of those events to occur. And that's why we just refer to it in seconds. There's no need to give a unit for the number of times something occurs. So in this particular case with number 5, we have to figure out which one of those two things we're given. The problem says a rate of 10 softballs per second. And so if that is your rate, it is the number of times one of those softballs got pitched, 10 per second, which means that this was a frequency that was provided to us, not a period. From there, you've got to go ahead and use the equation. So the equation for literally any wave, the velocity of that wave is equal to your frequency multiplied by your wavelength. That little upside down looking Y thing is the Greek letter lambda. And we're going to be using it probably a lot. I think officially in the textbook or on Microsoft Word, it looks a little bit more like this, but I think the squiggle is weird and stupid, so I just get rid of it and make it an upside down Y. It's really easy to write. Anyways, from there, once you have the equation, once you know whether or not you're dealing with period versus frequency, all you got to do is plug in the values that you were given. So in this particular case, you have for number 5A, a velocity of 300 meters per second provided to you, a frequency of 10 softballs per second, which is also 10 hertz. And then they ask you about wavelength, the distance between those events, right? In this case, you could think of each softball being thrown out as the crest of that wave. There's a lag time in between them. That would be the trough. And so you're going to get 10 occurrences every second, 10 crests every second. So literally just divide by 10, you get a distance of 30 meters. And that's all any of these guys needed to be. And then the other thing I wanted you to notice with letter B, because this was for letter A, for letter B is the relationship between wavelength and frequency. Velocity is equal to wavelength multiplied by frequency. And so if one of these values increases, then the other value is going to have to decrease. Velocity is going to be set. There's nothing we can do about it. That was one of the things that we should have noticed in the reading notes. The velocity of a wave is dependent only upon the medium. That's it. And so as wavelength increases, frequency will decrease, or vice versa. They're inversely proportional to one another.